Okay, we're going to look at a little friction problem here. And let's read what the problem says. It says two 40-kilogram crates are resting on a flat surface as shown. So this is a crate, and this is a crate. And it says the coefficient of static friction between the surface and the crates is 0.25. So I'll say mu s is equal to 0.25. So it'll be the same friction here as it is here. And then it says it is assumed that the two crates are connected with an inextensible cord as shown, such that if crate B moves, crate A must also move. So what we're saying here is there is a force applied to the crate, and I believe we need to give ourselves an angle in there, and we're going to say that that's 30 degrees. 30 degrees to the horizontal, so there's going to be a force applied here. And if crate B slides, this inextensible cable automatically makes crate A slide, so that they have to move together as a group. Now, if this is not an inextensible cable, this becomes a much more complicated problem, but we're assuming that it is an inextensible cable, and so we're going to work with that assumption. Now, it's pretty clear, if you think about this, that there would have to be a normal force here, and there would also have to be a normal force there. And it's also pretty clear that if this force is pulling to the right, then the friction here, we'll call it the friction force at B, will be like that. And there'll be a friction force at A in that direction. Now, with respect to the 40 kilograms, that means that the weight here is 40 kilograms times 9.81. And so if I say 40 kilograms times 9.81, that works out to be 392.4. So 392.4 newtons would be the proper dimension there. And this likewise would be 392.4 newtons, because both crates have the same mass, which is 40 kilograms. So how many unknowns do I have here? Well, trying to find what P is, so obviously that's unknown. I don't know what NB is, and I don't know what NA is. Now, the way this problem is worded, this problem is what we call a impending motion problem. What that means is we're trying to find the greatest friction force that could actually happen here and the greatest friction force that could happen here, because they would both be working together to prevent motion of this block. So this is not like some of the problems where we're trying to decide, does it slide or does it not slide, or what's happening. What we're trying to decide here is how much force is required to cause it to slide. So I think it's probably pretty safe to assume that under these conditions that force of friction at B will be equal to the maximum that it could be, which would be 0.25 times NB, and that the force of friction at A would be the maximum it could be, which is 0.25 NA, like that. So because that cord is inextensible in all the conditions that we've described here, both of these friction forces that are resisting motion are going to be at their maximum values. So you got here and here. And what that really means is that there's really only one unknown associated with this contact surface, and really only one unknown here and one unknown there. So we have a total of 3 unknown forces. And so maybe on a two-dimensional problem, if you think that we have a total of 3 unknown forces, we would be in good shape. because we can sum forces in the x direction and we can sum forces in the y direction, and then we can take moments about a certain point. But on this particular problem, we don't have enough information to take moments. So we have lost our ability to take moments. So that means that we only have two equations that make any sense. And that would be summation of forces in the x direction would be equal to 0. And we could also sum forces in the y direction and set that equal to 0. Well, if I have three unknowns and I only have two equations, I can't solve that. And there are no other equations of condition which would allow me to solve it. So then what I need to do is to break this guy right here into some independent free body diagrams that will allow me to then work my way to the solution. So that's the approach we're going to do. And I think what we're going to do is we're going to make a cut through this cable here. So let's just say we're going to make a cut through that cable, and we're going to draw a free body diagram of what's on the left, and we're going to draw a free body diagram of what's on the right. And then we're going to try to make a decision as to whether or not we can solve that.